Hello everyone, relative motion continuation. Na khavya chu 1D ball hin to hi 2D ball de. So if you remember in the previous video, so you have relative motion. Okay, suppose I say velocity of B with respect to A. So what is this? So this is velocity of B minus velocity of A, right? So velocity of B with respect to A to pitinam dele with respect to A na frame of reference to A to na. So imagine yourself as A and then you're observing B. Okay, so that means velocity of B with respect to A. So that way, how do we write it? We write it as VB minus VA. Suppose now in 2D, okay, I have XY. So let's say example two cars. So one car, say car A is going towards the x-axis. Velocity to that car A, so let's say 10 meter per second. Okay, so some random values. Car B is, let's say initially so it is moving downwards. Let's say value is 10 meter per second. Okay, so easy value. B, so let's say this B is at a distance of 100 meter, okay, away from A, right? So here I can ask you, so what is the velocity of B with respect to A? Okay, so that is the first one, right? So what is the velocity of B with respect to A? So that means VBA. Okay, formula so apply. So here if I apply the formula, VBA should be equals to VB minus VA, right? So here if you see, VA is how much? So VA is given as 10 meter per second and VB is given as 10 meter per second. Okay, but here in the 2D, so you cannot directly put the values here 10 minus 10 and get 0. Okay, as you choose A to B direction ki bang lau 1D relative motion also A to B to car ni example kila alchon amani to direction ki bang na, it is direction ki bang tina, so they are both moving in one dimension. Okay, so therefore A to B value direct na put va minus plus na bol thayo chilai hi B hi A hi x positive x langa chi ya B hi negative y langa chi chula na, so they are not in the same direction. Okay, so they are moving into different dimensions, x dimensions and y dimensions. So here what we can do is say VB plus minus VA. Okay, ita ibol ka jiham katile jihi vector khat so na jijong hi vector khat. So now I can take the resultant of these two. Okay, so resultant of these two using vector law of addition, right? A square plus B square plus 2AB cos theta square root, that big formula. So here I have A along this side, VA. Okay, so VB is downward, right? But here in the equation I want minus VA. Okay, so then where is minus VA? VA to z langa hi minus VA to opposite v langa hi ngai na. So here I have minus VA along this side. Kutile resultant to ipile pi ngai cha VB to minus VA ngai cha chula na, VB chalaya ma V minus VA chalaya ma, kutile amani resultant hi hold cha. So that means the resultant of these two will be along this side. So this is VB plus minus VA. Okay, so this is the resultant. Magnitude. So what about the magnitude of this resultant? If I apply vector law of addition, value so VA is 10 na minus VA is also 10 magnitude so VB is also 10. So therefore if I find the magnitude of this resultant, so I will have here 10 square plus 10 square plus 2 into 10 into 10 is 10 square cos 90. Angle between minus VA and B is 90. Okay, so therefore cos 90 is what? 0. So here I will have 10 root 2 meter per second. Okay, if you solve that one, see what is this 10 root 2? So 10 root 2 is velocity of B with respect to A. Okay, so this value comes out to be 10 root 2. meter per second. Kutile kasi banga chu video masa one dimensional say banga chu velocity of b with respect to a means if you are at a, okay, that means a is at rest. Na nang no mum na chu, so the frame of reference is always at rest. Okay, so that means if a is at rest, so b is going to move with 10 root 2 meter per second. Okay, so that means chila direction pa hai na, so this is nothing but vba. Okay, if you are at a and rest, then you will see that b is moving in this direction, right? So here if you are a here, you will see that b is moving in this direction with 10 root 2 meter per second. Okay, so this is what is happening here. So here I can write if I am at a, where do I, okay, right here, if I am at a, okay, so the y-axis, I will see that b is moving along this side with 10 root 2 meter per second. Okay, then how much angle? The angle is at them, this angle. So here I have 10 root 2, right? Resultant is 10 root 2. I will have formula apply to it. So here let's say alpha. Okay, alpha. So alpha will be given by 10 inverse of, right? So 10 into sine 90 divided by 10 plus 10 cos 90. So here if you solve, you'll get 10 inverse of, so sine 90 is 1 and 10. Okay, so 10 inverse 1 is that, huh? So this is 45 degree. Okay, you'll get the angle as 45 degree. So here alpha is what? Alpha is 45 degree. Okay, so here b is going to move with 10 root 2 meter per second. It makes an angle of 45 with a. Okay, so that is the final answer. So here one more thing I can ask you, what is the minimum distance between a and b? Na b a chu chilang chi ding, okay, b jong chu chilang so ding. So what is the closest distance a and b come across? Okay, right? So that is the question. So here that I can find it from here. See, if I am at a, I will see that b is coming like this. Okay, so if they ask you closest distance, minimum distance, then you draw a perpendicular line like this. Okay, so this is your minimum distance, right? You know how much is this? This is 100. Okay, so this is 100. So you have 45 degree. So now you can apply sine theta. Okay, so here sine 45 will be equals to d minimum divided by 100. Okay, so therefore d minimum will be what? 100 into sine 45 to by root 2. So you will have here 50 root 2. Okay, so that is the minimum distance between a and b. Okay, let's do one more. For example, same question. Okay, x and y, chila hi origin hi so a is moving along this side, let's say 6 meter per second. Okay, abana b2, so now instead of coming down, b is going along this side. Okay, let's say 8 meter per second at some angle, how much? 37 degree. Okay, so here I'm asking you, what is the velocity of b with respect to a? Okay, that is the question. So that means vba. Kutile formula chupita vba to vb minus va. Okay, so what is vb? 2d, so you cannot do direct addition subtraction. Okay, so here I will write vb plus minus va. Okay, kutile chila hi vidachun va2, it is along this side. Okay, and where is vb? So vb is along this side, so at 37 degree, right? And now, okay, now I need to find minus va. A formula have tang sila addition ading so minus va ngai cha chula na ji cho hoilang am de ha, so opposite to va, so this is minus va. Okay, hutile chi hi 37 ki pichuna question achong vector addition holding as a vector ten ka angle to head ngai chola. So between VB and minus VA, what is the angle? So that angle is this. Okay, this is 53. Chipai 37 hile, chipai 53 hi ngai na. Kutile formula juka mana le iping pot de ha. So the magnitude of VB plus minus VA. So this is equals to minus VA to ham magnitude. So this is 6. Okay. So VB magnitude is how much? 8. Okay. So here I will have 6 square B, so 8 square plus 6 square plus 2 into 8 into 6 into cos 53. Okay, so here you have to solve some values, right? So this will be the magnitude, whatever you got here. So how much is this? 8064 plus 6036 plus 8 to 16. 16 into 6 is 96 into cos 53 to that 3 by 5. Okay, so some dirty value will come out. Now advance or ball and bench. So the way to do is that is important. Okay, the concept is important. So whatever here you answer you got here, this is your velocity of B with respect to A, the magnitude. Okay, so that resultant is along the side. Now value okay, so these values are a little bit complex, so I will not do further on this. Velocity of B with respect to A whole done. So the important thing is this part. Okay, here you have to convert VA plus, so here you have to write minus VA because you can only apply vector law of addition here. Okay, so therefore you have to try to put plus here, right? So on this side you have VA, so this side should be minus VA. Okay, like that. Okay, let's see one application of this one. Okay, a rain main problem. Example, okay, a main is going under a rain. Okay, so there is a rain falling. So he is walking, right? So let's say this man is walking at speed of velocity of man, say 3 kilometer per hour. Yeah, go here. So rain is falling vertically, right? So go so rain is falling vertically. So let's say the velocity of rain is 4 kilometer per hour. Okay, he is holding an umbrella. Okay, he is holding an umbrella. So the question is, at what angle with the vertical? Okay, so should he hold his umbrella so that he does not get wet? Okay, that is the question. So this is an example from NCERT. Question is, at what angle with the vertical should the man hold his umbrella? Okay, so that is the question. So velocity of man means the velocity of man with respect to the ground. Okay, so the frame of reference is the ground frame. So here I have that the velocity of man. So this is along the plus x. Okay, and then I have velocity of rain is downward. Okay. See, if you want to know how should the man hold the umbrella, you have to know how the rain is falling upon the man, right? You imagine yourself as the man, so you see how is the rain falling on you. Okay, at what angle it is falling upon you, you should know that, so that you can know where to put the umbrella. Okay, so that means we need to find out the velocity of rain with respect to man. Okay, if you imagine yourself as the man, so how is the rain falling? Okay, so there is the velocity of rain with respect to man. So this is what? So this is velocity of rain plus, not plus, minus velocity of man. Okay, that's why easy bang wacho. So this one I can write as velocity of rain plus minus velocity of man. Okay, so that means where is minus velocity of man. So this is minus velocity of man. Okay, so now I have to find out the resultant of VR and minus VM. Okay, so VR is this and minus VM is this. So I have to find the resultant of these two. So the resultant of these two will be somewhere on the side. Okay, velocity of man, velocity of rain with respect to the man. So how much is that? So velocity of rain to 4, velocity of man to 3. Okay, so therefore this will become 3 square plus 4 square. Okay, so 2 into 3 into 4 into cos 90. Angle between 3 to 4 to 90 chula. So I'm just neglecting the rest of the part. Okay, so here what will you have? 5 kilometer per hour. Okay, so the velocity of rain with respect to the man is 5 kilometer per hour, and at what angle? The angle is at alpha here. So here alpha will be 10 inverse. Okay, so 3 into sine 90 divided by 4 plus 3 into cos 90. So how much is this? So 10 inverse, so 3 by 4. Okay, sine 90 is 1, cos 90 is 0. 10 inverse 3 by 4 pm, so that is 37 degree. Okay, so now we know the value of alpha. So we know that the rain is falling down at an angle of what? 37 degree with the vertical. Okay, so that means the man has to hold his umbrella. How? You have to put the umbrella like this. Okay, so at what angle? So this is 37, so therefore this should be 37. Okay, he has to hold the umbrella at an angle of 37 degree with the vertical. Okay, so that is the answer. So next you have a river boat problem. Okay, so this is very, very important. You know a river. Okay, I have a river. So it is going like this. So the velocity of river with respect to the ground. Okay, so that is VR. Okay, suppose you start a boat. Okay, a boat is here, B-O-A-T, Zahas na. So if he tries to go like this, okay, if he tries to go like this, so do you think the boat will go like this, straight? So the path of the boat will be something like this. Okay, right? It is not straight, it will be something like this. Right? So if the boat tries to go straight, so due to the motion of the river, he will be dragged. Okay, that means the river drags as a path. So na, ground apart valuation boat path. Ground apart valuation boat path. Okay, you will go along this path. So then tell me, what is the velocity of boat? Okay, so which one is the velocity of boat? So when we say velocity of boat, okay, so this is with respect to the ground. Okay, so here when I write VB, so this is the velocity of boat with respect to ground. Okay, ground frame. So that means if you're standing on the ground and looking at the boat, so Zahas china path na iti chidam. So if you're standing on the ground and looking at the boat, you'll see that the boat is moving along this path. Okay, so that means this is the velocity of boat. Okay. Then what is the velocity of boat with respect to the river? Next you have another term, velocity of boat with respect to the river. Okay, so what is this? So this is a velocity of boat with respect to river. Na, so velocity of boat with respect to river kati alachun. So frame of reference to river chula na. So if you imagine yourself sitting in the river, okay, you're sitting on the river and then you're flowing along with the river. So to you, the river will be at rest. Okay, right? The frame of reference is always at rest. Okay, if I say velocity of boat with respect to the river, so the frame of reference is the river, and then you have to imagine the river as is at rest. Okay, if you imagine the river is at rest, so what is the velocity of the boat? So velocity of boat with respect to the river. So sometimes in question this is given as velocity of boat in still water. Okay, so still water so most of the time student gets confused. Okay, if you concept velocity of boat in still water to velocity of boat with respect to the ground so you may think like that, but that is wrong. Okay, so velocity of boat with in still water means it is the velocity of boat with respect to the river. Still water so this is race na still so that is possible only when you sit on the river and observe the boat. Okay, only when the river is the reference, the frame of reference. Okay, so here or this is also given velocity of boat with respect to the river velocity of boat in still water so velocity of the boat if river is at rest. Okay, so where the boat tries to go, okay, that direction. So that direction is the velocity of boat with respect to the river. Okay, so that means in this question, in this example, so this is VBR. Zahas chikut na lang na. So that is the velocity of boat with respect to the river. Okay, so these things you have to be clear first. Velocity of river so chita so na chipeni halo. Okay, so ground upper unknown va boat in the vala boats in lang patso. So where the boat is actually going as seen from the ground, that is VB. Okay, and then what is VBR? So the velocity of boat in still water, or the velocity of boat with respect to the river. Okay, or the direction where the boat is trying to go. Okay, so that is the VBR. Okay, so let's see some important relation. Suppose I have a river, so this is velocity of river. Okay, suppose I try to go in general. Okay, let's do in general. Boat so go na. So let's say it is trying to go along this side. That means this is VBR. So making an angle theta. So on this side I have VR. Okay. Relation pita. Velocity of boat with respect to the river equals to velocity of boat minus velocity of river. Okay. From here I can write velocity of boat is equals to velocity of boat with respect to the river plus velocity of river. Vector resultant parts na velocity of boat. Okay, the velocity of boat will be given by the resultant of VBR and then VR. So here you have VR, here you have VBR. The resultant will be along this side. Okay, so that means VB will be this. Okay, right? So now what I can do is I can see kasi sa VB2, if you're sitting on the ground and looking at the actual path of the boat is VB. So that means if the boat goes like this, okay, so so here the time taken is one thing. Okay, question can be asked here, how much time is taken? So this, you see, so this is the exact opposite bank. Okay, river bank na. Now you see it landed here. Okay, so that means there is some displacement here, right? So we call this drift. Okay, so this part. So how much the boat has drifted from the opposite bank? Okay, drift. Right, and then let's say the width of the river will be given in most of the questions. So this is width of river. Okay, so here one thing I can do is VBR is neither along X and Y. I can do component, those things. I can take the component of VBR. So here I have VBR cos theta. Okay, so on this side I have VBR sine theta. Okay, now everything is XY. Overall movement is towards the right. Okay, so that means VR is greater than VBR sine theta. Okay, VBR sine theta. Kutile X to Y got na. Suppose this side is X and this side is Y. Kutile Y langa motion hina. Who is responsible for this Y motion? So which component of velocity is responsible for this Y motion? Okay, vertical motion na. Kutile chalai ta chi component oma chi component chala na. He chi kutile Y langa motion hi koi pen hi responsible ha. So VBR cos theta is responsible, right? You know, along this motion. Okay. So if you are given D, okay, in many questions will be given D. So if you are given D, so you know the vertical component of velocity is VBR cos theta. Okay, so VBR everything will be given. Kutila time to reach the other end. So distance divided by distance to width of the river, divided by the velocity which is along the vertical. Okay, so that is what VBR cos theta. Okay, so this is the first one. Okay, na bank ako na. So from here to the other bank, so how much time it takes for the boat to reach? So this is the formula. And next thing is, so the drift. Okay, drift to chilang x lang direct chi chula na chi. Kutila drift pa who is responsible for this drift? So the resultant of this and this. Okay, so like I say, see along this side I have VR minus VBR sine theta. Okay, along this side I have VBR cos theta. So like component la neke practice ngai. Oh, you have to know how to take component here. So now we see that the horizontal component is responsible. So this component of velocity is responsible for horizontal movement. Okay, so therefore if I want to find out drift, so this is speed into time. So like distance, is that told on tela. So here this distance is given by speed into time. So what is the speed? So I want to find out drift. Okay, so drift is equals to, so speed is this one. So VR minus VBR sine theta, okay, into time so D divided by VBR cos theta. Okay, so this is your drift. Khatsa bayar ngai lo ang podo dan pa hai na component kila dan ho time ki derive dan ho na distance by speed iman ho speed into time iman ho. Just remember only this basic thing. It's a formula hoi bayar ngai lo. Don't try to bayar. Okay, so one more thing. You have minimum distance question. Sometimes they ask you. So what is the minimum distance? Minimum distance. Suppose I have a river. Okay, kutila boat okay, it tries to cross the river. So this is VR. Kutila minimum distance minimum distance or minimum time so so in which direction the boat has to go so that it travels the minimum distance. Okay, so only when you travel in this direction vertically. Okay, only when you travel vertically, so there you will take the minimum time, you will take the minimum distance. Yeah. Okay, see, this has to be VB. Okay, so VB has to be exactly perpendicular to the river. Okay, so in order to travel in a shortest path, so here if you want to get VB like this, so you have to try to go along this side. Okay, na aji chito hin chi resultant hin VB api chula. Okay, if VB is along this side, then VBR should always you have to try to go along this side, because the river is also pulling you that side. So only when you try to go along this side, your path will actually be like this. Okay, so let's say at an angle, so this is VBR, VB, so let's say this is theta. Okay, so similarly here I can split VBR. Okay, if I split VBR, so this is VBR cos theta. Okay, so this is VBR sine theta. So along this side I have VR velocity of river. Velocity vector name. So okay, you have two vector. You want the resultant vector to be along this side. Okay, now velocity vector component velocity thumta. So if you want the net velocity to be along this side, so these two has to get cancelled out. Okay, now cancel out. If these two gets cancelled out, what is the remaining? So the remaining is only this component is along this side. Okay, so we want the resultant to be along this side, so the resultant should be properly vertical. Now we want properly vertical, so it is possible only when these two component gets cancelled out, so the remaining is this. So this moves properly vertical. Okay, so that means if you want to travel in the shortest distance, so the minimum time, so what is the condition? So the condition is that so this and this has to cancel out, and it is possible only when they are equal. Okay, so for shortest path, okay, minimum distance, whatever you want, you can say. So VBR sine theta should be equals to VR. Okay, so this is the condition. Just remember, na? Okay, so let's try to solve some question. So first question is from H.C. Verma. A river is 400 meter wide, is flowing at the rate of 2 meter per second. 2 meter per second here. So here 2 meter per second is the velocity of river. Okay, so a boat is sailing at a vertical at a velocity with respect to the water. Okay, so that means this is what? So velocity of boat with respect to the water. Okay, the river, and then in a direction perpendicular to the river. Okay, so let's see. You have a river, right? So here a boat is sailing direction perpendicular to the river. Okay, like this. So this is VBR, right? So this is VR. VBR is at 10. Okay, so VR is at 2. Okay, questions of him. Find the time taken by the boat to reach the opposite bank. Width of okay, width is given, right? So width is given as 400 meter. So question is, what is the time? Okay, so here I say this is easy. So here you have a one component of velocity along this side. So this is 10. You have the width is 400. So time will be simply 400 divided by 10. Okay, as it's a VBR is directly vertical. So time will be A part. So time will be 400. So width is divided by component of velocity along along the vertical. So that is how much? 10. So this will be 10/40 second. Okay, B part. How far from the point directly opposite to the starting point does the boat reach the opposite bank? So how far from the point directly? It's like point here. So this is the point directly opposite. So if VBR is this, if the boat tries to go like this, so since the river is pulling along this side, so VB will be actually along this side. Okay, now this is VB. Okay, the actual path of the boat. So VB will be along this side. So this is VB. Questions in Vietnam. Now the question is asking you the drift. Let's say this is X. So how far from the point directly opposite to the starting point does the boat reach the opposite bank? X should be so X will be speed into time. Which is speed become horizontal component see, since this motion is along the X here, so this X is due to the horizontal velocity and okay, horizontal velocity, right? So that means I have to write here 2 horizontal lang hai 2 ba sila na 2 into 40, so that is 80 meter. Okay, so this is the drift. It is a basic question, so it is easy. Okay, next one. A swimmer wishes to cross a 500-meter wide river. You have a river. So this river is 500-meter wide. Okay. And the river is flowing at a 5 kilometer per hour. So his speed with respect to the water, so the swimmer's speed, velocity of swimmer with respect to the river, so this is given as 3 kilometer per hour. Question to him: if he heads in a direction that makes an angle theta with the flow, so find the time he takes to cross the river. So let's say he makes some angle with the, so this is a, he tries to go like this. Okay, v of swimmer with respect to the river, so he makes some angle theta with the flow, so the flow is along the side. Let's say this is theta. Okay, then this is v of river, right? So VSR is neither along xy, so you take component. So one component is this, so this is VSR sine theta, and another component is along this side, so VSR cos theta. Okay, question should be the find the time he takes to cross. Time also na. So whenever time is asked, you see which component of velocity is along the vertical. Okay, so because this velocity is responsible for the vertical motion. A part 2, time. So time is what? 500 meter divided by VSR sine theta. Okay, so theta is just given theta. So 500 divided by VSR is 3 kilometer. Okay, 500 is meter, so 3 kilometer to 3000 meter. Okay, divided by, so let's find the time in minutes. Okay, so that means so here is by hour. So if you want to write by minutes, you have to divide by 60. Okay, so sine 30. So 0 0 cancel out, 0 0. So 3 1 is 3, 3 2 are 6, 2 goes up. I will have here 10 by sine theta. Achiever mazong answer it. So let's put the answer like this. And B part. Okay, what is the B part? Find the shortest possible time. Okay, so now they ask you the shortest possible time. For a shortest possible time, so here I will just try to redraw something. Okay, so here I have one vertical component. So here theta value is also not given, but anyway, okay, so I'll just show you how it is, how this solution is there. So shortest possible time. So here the velocity, the boat should go along the vertical. So here this should be 3 kilometer per hour. Okay, and the river is going along this side with 5 kilometer per hour. And if you see, so here the vertical component of velocity. Okay, so it is you may have a problem, but here actually this 3 kilometer per hour should be vertically upward. Okay, so this is the vertical component of the river. Time, so this is responsible for the time. Okay, so the vertical part, vertical motion. So therefore the time will be B part of time 2. So here time will be, so total distance of 500 divided by speed to 3 kilometer. So 3000 divided by 60. Okay, so how much is this? 2. So this is 10 minutes. Okay, so we'll do it like this. So the important thing is you should know the concepts. Okay, time ang kido alachun vertical component velocity chuna. So whatever vertical component that you have, you take and divide the distance. Okay, by that speed. And if they ask you the drift, then the horizontal velocity into time, right? So that is the concept. Okay, so a question has been asked in medical exam, from 2019. So let's see the question: the speed of a swimmer in still water. Still water ka sa pita. So with respect to the river, right? So velocity of swimmer with respect to the river. So this is given as 20 meter per second. Okay, so the speed of the river, right? So this is VR. So this is also given as 10 meter per second, and it is flowing due east. So that means the whole thing is like this. So velocity of river towards east, northeast, southwest. So okay, it will be like this. So this is east, so this is north, so west and south. If he is standing on the south bank, okay, so the man is here and wishes to cross the river along the shortest path. Okay, now you have the word shortest path or minimum distance. So that means if you want to go the shortest path, so there will be VB along this side. VB, V of boat or velocity of swimmer. Okay, so at what angle he should make his stroke with respect to the north? So at what angle he has to try to swim? Okay, the man has to try to swim at some angle along the side, making some angle theta with the north. Only when you try to swim along this side, then the path will be like this. So the path is possible to get like this. Vertical component path, so it will become like this. Okay. So same thing, you just split the VSR. So if you split the VSR, along this side I have VSR cos theta. Right, along this side I have VSR sine theta. Right, along this side I have VR. Resultant part vertical hinting on condition to pita. So these two has to get cancelled out. Okay, so they have to be equal. So therefore I have VSR sine theta should be equals to VR. Right, so what is VSR? VSR is 10 sine theta equals to VR to 20. 0, 0 cancel. Okay, wait. So the value is, so VSR is 20, so VR is 10, 0, 0 cancel. So here sine theta is equals to 1 by 2. Kutila theta to 30 degree. Okay. So he has to go 30 degree towards the west. So this side is west, left side is west. So towards west he has to go 30 degree. Okay, so that is the answer. Okay, last one, 2, Siemens question. A river is flowing from west to east direction. Okay, west to east direction with the speed of velocity of rivers that have 9 km per hour. If a boat capable of moving at maximum speed in still water, still water jo so this is the velocity of boat with respect to the river. Okay, crosses the boat time kipi. So it takes time equals to 0.5 minutes. Okay, while moving with maximum speed at an angle of 150 to the direction of flow. Okay, that means it will go here. So this angle is 150. So this is velocity of boat with respect to the river. 150, so this will be 60, right? So 90 plus 60 is 150. Then the width of the river. Okay, so now they ask you to find the width of the river. So let's say this is D. Okay, now I think you can split that VBR, right? So you split that VBR, what will you get? Along this side I have VBR cos 60. Okay, so along this side I have VBR sine 60. So this side I have VR, right? Velocity of river. So who is responsible for the vertical motion? Kasi so time ang kito palatun. So this component is responsible for the vertical time. So therefore, so time will be equals to distance divided by, so VBR cos 60. Okay, so here what is D? So D equals to VBR cos 60 to 1 by 2 into time. Okay, so right, you put the values. VBR is 27 km per hour. So here I want to write, answers are given in meters, so I have to write in meter. 1, 2, 3 per hour. So I want to do it in minute because time is given in minutes. So divided by 60, okay, into 1 by 2 into time is 0.5, that is also 1 by 2. So you solve this. 0 0 cancel out. 3 2 are 6, 3 9 are 27. Okay, so what is 900 divided by 8? So 8 1 is 8, 8 1 is 8, 8 2 are 16, 8 5 are 40. Okay, so 112.5. Okay, so that much for this video. I hope you understand. Kinematic sungana video zo si topic zo si chu abona. So that much we have done. Okay, so every topic we have finished. I will put all of this in one playlist, right? Khotila abana ko next lecture apal ako motion loss of motion ipat diuta. So okay, so I hope you understand. Thank you for watching. So I'll see you in the next video.